So the basic principle of electrophoresis is that any charged particle will move in an electrical field. Don't we know this already? We know this, right? Because if it's positively charged, it will move towards negatively charged electrode. I hope you all understand that an electrical field is created using two electrodes. One is negatively charged electrode, the other one is positively charged electrode. So whenever you place a positively charged particle in this electrical field, where will it move? It will move towards negatively charged electrode. If you place a negatively charged particle, it will move towards positively charged electrode. So what is the basic principle here? Any charged particle will move in an electrical field. And the velocity of migration of a charged particle in electrical field is given by Z by F. So what is the formula? Velocity is given by Z by F, where what is Z? Z is the charge and F is the frictional coefficient. Frictional coefficient is determined by shape and molecular weight. Okay. What are the three factors which determine mobility of a particle in an electrical field? Number one is charge. Number two is shape. Number three is molecular weight. Do you think this is difficult to understand? It's conceptual, right? What will happen if a particle has more number of charges? Rapidly, it will move towards the oppositely charged electrode. So, number of charges and the rate of mobility are directly proportional. So, V and Z are directly proportional. That is why Z is placed in the numerator. What will happen when a particle is heavy? Heavy particle cannot move. So, velocity and molecular weight are inversely proportional. So, where should you place a molecular weight? In the denominator. That is why V is equal to Z by F, where Z is charge and F is the frictional coefficient, which is determined by molecular weight and shape of the particle. Okay, this way if you try to separate proteins in electrophoresis, by proteins I mean to say are serum proteins, right? So this way if you're trying to separate, have you seen serum protein electrophoresis being done? Yeah, usually serum protein electrophoresis is done on a glass slide, something like this. Sometimes we also use a membrane, and what I've shown you here is a simple glass slide. On this glass slide we apply a support medium. The support medium is most commonly agarose. After applying the support medium, towards one end of the glass slide, we apply the serum, protein of which has to be separated using a pipette. Do you see that? I've applied the serum towards one end of the glass slide using a pipette. Then I place the slide in an electrophoretic tank. I'm going to fill up this electrophoretic tank with an alkaline buffer of pH 8.6. So why am I insistent on adding an alkaline buffer of pH 8.6? Because only then all these proteins will sense the alkaline pH. They try to neutralize the alkaline pH. To neutralize the alkaline pH, they give off their H+. When they give off their H+, they become negatively charged. So what is the purpose of adding an alkaline buffer? It is to provide uniformly negative charges to all your proteins. Do you understand this? Now, after giving negative charges to all your proteins, you connect this electrophoretic tank to an electrical supply. Close to the point of application is connected to a negatively charged electrode. The opposite side is connected to a positively charged electrode. So, when you switch on the electric current, because all your proteins are now negatively charged, they start moving towards positively charged electrode. The migration here is affected by three factors. What are the three factors I told you? Charge, shape and molecular weight. That way, all your proteins get segregated into 5 bands. Now, what are these 5 bands? The band that is present, do you see 5 bands here? Right? So, how many bands can you see normally in protein electrophoresis? 5 bands. The band that is present farthest from the point of application is the albumin band for obvious reasons. Why do you think albumin band is the one that is present farthest from the point of application? Because albumin has got the least molecular weight, it can move the fastest. That's not the only reason. The other reason is albumin has got the highest number of negative charges. So more negative charges, very less molecular weight. That is why albumin moves the fastest and is present farthest from the point of application. After albumin band is an alpha 1 band. Okay, the next band is alpha 2. Then we have a beta band and finally we have a gamma band. So these are the 5 bands that are present in protein electrophoresis.